Hello, Daryl here. The channel is Programming in Any Language. The supporting website is www.black-duck.com. You'll find the videos and the PDFs of the code there in most cases. The video is Anything Database Version 4 Part 1 Planning and Design. That's a mouthful. In this series of videos, I'm taking the Anything database that I constructed in the Structures section and changing it to use a class instead of a structure. There will be some parts of the series of videos that will be identical to the structure series, but many of the parts will be different. The biggest difference will be in the amount of coding needed for the application itself. Because all code manipulating the data is contained in a class, all the actual application has to do is do the functions of the database type program. Once again, we'll be storing the data in a text file, but it will be formatted to be easily ported into a database or a spreadsheet. The application is broken down to 9 parts. They are analysis and design, adding records, navigation, saving records, loading records, editing records, deleting records, clear the file, and searching records. We'll start with part 1, analysis and design. When working with classes, most books tend to give you some pretty good examples on how to actually create a class and make it, structure it. Unfortunately, classes and learning how to use classes is kind of difficult because you don't really have a reason to use those things, or at least you need to figure out a reason to use them, because it seems kind of, well, why do I want to complicate matters when I can write my program without using a class? And you certainly can. The thing about it is you need to see an example or an application that is more extensive, where you can actually see the class that you're actually going to create and where it actually is beneficial for you to use one. And we're going to try to do that here. Up to now, we've seen a number of the Anything database. We're going to look at the Anything database version 4, part 1. That's what this one's all about. But prior to that, we did a couple other versions. We did the speed track lesson, which is the Anything database version 1. It was a simple piece. It was kind of designed for people who have had some programming experience. We're getting into C# for the first time and wanted to see how to use the if statement, the loops, and all this other stuff, and file processing, and get it going. And the speed track lesson certainly does that for you. And you can see that session right here. It's a very small version of the Anything database, which just tracks a bunch of things in a form. And that's it. After that, we got into arrays, and this gives us a chance to actually create the list application, which is the Anything database version 2. And it has the add, edit, delete. That's what we might use in a database, and some navigation controls, and be able to display one entry in your database, even though you might have thousands of entries in here. And here we have actually 5 in a record count. But we can actually go through this and make it useful by using a list in our application and being able to track the list of pointers that'll pop up the record that we're actually looking at. And that worked pretty good too. But as we step forward, we began to learn about structures and how we could build something that looked more like something we'd use in a database. And databases typically, as you'll see shortly, have data that's of a fixed size. You generally have, for example, if you're keeping a last name field, you're probably going to let the last name field be a certain number of characters long, maybe 20. And so everybody who has a last name is going to go into that database as a field of 20. If your last name is Smith, you're only going to have 5 letters, but we're going to put it in that little spot. If it happens to be a long name that has more than 20 characters, we're going to truncate some data and just put in the first 20 characters. And making that useful is then you can pop it into your database and save it. And version 3 gets into that using the structure. And you can see right in here, we've got basically the database right here with add, edits, searching capabilities, all that. And you're seeing the entire record being displayed here. And we have fixed sizes for these fields. And when we actually pop these things out, we can put them into a spreadsheet or a database or whatever else we want it to do and make it all work. Although we're still only using a text file to save our data at this time. We haven't explored databases yet. We're going to be exploring that in the next chapter, a couple chapters down after OOP, and then we'll get use in that. But version 3 got pretty close to being a pretty good looking database that you might want to create and use, and this structure does it for us. We want to go into version 4, which is using a class to do all this kind of thing. And one of the things you're going to find out is that when we used Anything database version 3, it was busy. There was a lot of data, a lot of programming we had to do to make things work for our database, truncating fields, adding spaces to fields, and so on. And what I'm doing with the class here is we're going to use a class to create this person file, which is going to hold all of these things here. But it's going to do more than that. It's going to allow you to format that data inside the class so that your actual program that's running the add, edit, delete, search, and all this other stuff here is going to be more simplified. It won't have to worry about structuring the data and keeping track of it. It can just bring in the data and put the data out and go on from there. That's what we're really getting into with using a class here. And it kind of demonstrates that, oh, hey, classes do have some meaningful pieces to it. We can actually use these things successfully to make things work for us and make things easier for us when we actually write our program. So that's what we're going to do with this thing, the Anything Database version 4, using a class. To begin with, we need to do the planning and design. That's what this section part 1 is all about. We're going to design and make this thing work. And just as a quick review, a database is a data management system, software that manages a large collection of data stored in a database, organized in tables and rows and columns. And you can see there's a table right here, the database, and we've got rows and columns here. We've got a first name field, middle initial, and this is basically a spreadsheet is what it is. It could also be a table in an Access database or a SQL database or whatever. And that's up to us. Where it's going to go isn't going to matter so much as how we actually maintain the data. For now, we're going to stick with the text file and save it in a comma-delimited file that can easily be ported to a spreadsheet or a database. Each column is called a field. Each row is also a collection of related columns. Each row is typically assigned an index, making it unique from any other row. We have the index right in here, 1, 2, 3, 4, 5, 6. And each field or column is a set size or data type. So we're always going to have strings in the first name field, for example. And it's going to be X number of characters long, maybe 20. Middle initial is probably going to be 1 character long, always. Last name, we might have 20 on that one, 25, I don't know. Address line might be 35 long. City, state, we end up creating what we want these things to be when we actually put this thing together. Right? Your database analyst is going to do this for you, or you're going to do it in a smaller shop and create this, and you'll do it ahead of time. How big should you make a last name? That's up to you. Take a look at names, analyze them, and see what you're coming up with and what you'd actually need. It could be that you have a lot of room on a huge, giant pool of last names that will take up 40 characters long. It's probably unnecessary, but you want to take a good look and see what's the reasonable amount of space to allocate for a database in the last name field. So you'd be setting all this stuff up. If we take a look at a design view in this happens to be Access right here, a design view, we can change the properties of fields. So you're going to see that all these fields that we saw back here, all these guys right here, can be located in a database with names. And then the data type is sitting in here. And you generally have properties you can set them to. 15 characters long is the only one I'm interested in right now. But you've got text alignment fields, validation rules, all that kind of stuff, that you don't have to worry about. In fact, we're not going to be using a database right now. We're going to be using a text file, so we don't have to worry about it. But we are going to be conscious of creating something that's going to be a certain size. In this case, the first name field is 15 characters long. When working with an application that receives or prepares data for the database, we use text processing methods to format the data to the correct sizes. And keeping a reference of the field names, data types, and sizes greatly helps the programmer no matter what language is being used for the application. We have this particular list here, what it is, how long it actually is, and having some of this on the side, actually printing something like this out, if you have it when you're creating a database work, is nice because you can keep it on the table on your desk right next to you, so you always know what size these fields are you're working with when you look at first name field. And first name might be a variable, it might be a text box, it might be a label, and you're going to want to concentrate on just what that's going to be and how much room you're going to allocate for it. So having this handy next to you is a good thing to do. Now the application, it's going to look something like this. We're going to collect data for a database that can be accomplished by creating the application that collects the data and saves it to a text file. So we've got our add, edit, delete function, clear, search, load, save, and exit. We also have update and cancel are behind these buttons right in here. You'll see those as we start to develop this thing. This thing happens to have 4 records in it. We're sitting on record number 2. It's Tweety Bird, and you can see slightly lighter text, and we can do all this kind of stuff. We did this in version 3. And now we're going to be using it in version 4, but class is going to be helping us. Using text processing methods, the data can be captured, the correct data type and size for each field. And this is what it looks like. If we actually take our data and expand it after we've collected some data here, this is the comma delimited file. And you can see Daffy with a bunch of spaces and a comma. M, the middle initial. Duck has a bunch of spaces and a comma. So we can easily extract the name by just grabbing the field from 0 to a certain number of characters out. We know we have the entire first name field. Middle initial we know starts in this particular column, and it's only one long. The last name starts in this field and is so many little characters long, and so on. So you can easily grab this stuff and bring it into the file very easily. The data from the comma delimited file can be easily transported to a database table. It can also be imported in a spreadsheet, and you can see it right here. It is in the spreadsheet right here. It's popping right in and being placed in its field that we actually need. So that works out well. To build this application in version 4, we need to create a hierarchy chart to identify the functions and methods that we want to perform this data. We also want to design a class to handle data. That's something we hadn't done before in our structure version of this thing. We want a class to be set up to hold the data for us, or at least to work with the data for us. We're also going to design a form so it's pleasing and functional to the user. That's what the user is actually going to see. The class is going to be in the background. We're going to write code for each function and method, and we're going to test the program and correct any issues we might have. There's always some issues, but the more upfront work we do, the less time we spend testing and correcting any issues in the program. This is what our application looks like, the Anything Database version 4, the class version. This is really no different than the structure version in what we're actually doing here. We're going to have navigation, being able to go top, bottom, forward, and back in our database, and we're going to display the results. We're going to have delete, add, edit, search, clear, and load and save buttons here, which are all be functions that we're going to be able to do. Delete is going to simply remove the selected record and display a count. Save is going to open a stream writer, select the upper file, write the list, and go on from there and close the file. We don't see anything in the class in here because that's in our programming piece, and we'll design that and put that together as we start to write our application and make this thing work. But altogether, everything is kind of the same. Add is going to be adding a list of the record. We're going to flip buttons so that we can't let the user get out. He's going to have to either update or cancel. And if he doesn't add, if he presses the add button and suddenly realizes I didn't want to do an ad, he can cancel. Or if he does want to do the ad, he can do an update and add the data to that. So those flip buttons are part of it. And edit is the same thing. We're going to be able to go into edit, cancel, update, and cancel. And we also have a search key right in here, which is also going to flip the buttons, but it's going to allow us to do a find or a cancel. So we're going to be looking for something in the find and displaying the results on our screen. We have a clear, which is going to wipe out the entire thing out. Load is going to bring any data we want to save in the past. And save is going to actually save that data so we can load it again the next day or whatever. And of course, our exit button is sitting out there. Now, to build the application, we are going to design our form. And this is basically what it's going to look like. We've got all the fields assigned here. We've got the LBL count, record count, which is going to tell us how many records we have in our database. Remember, our database starts at 0 and goes on. So we're going to actually increment that by 1. And if we have 1 record out there, even though it starts at record 0, we'll call it 1 record. In this case, we have 3, so we have records 0, 1, and 2 sitting in here. And it's going to keep track of that for us. This tells us where we are. We're at the top of the file, record 0. And we're looking at Daffy Duck in here. Label user message is going to be sitting here. So different messages can be displayed here in red. The last name, middle initial, text first name, address, line 1, 2, city, state, and zip are all sitting in here. We are going to use a search box, text search name. It's going to be hidden behind the text last name down here. So we'll apply this when we actually want to do a search. We'll flip the text boxes around so the user can type into the search name into a text search name box and be able to get that function working for us. And we've got navigation buttons that allow us to navigate through this, forward, top, bottom, everything, so on. And we've got our buttons that are going to do all our functions for us, the add, the edit, the delete, the clear, search, load, save, and exit. And of course, button update is hidden behind here, and button cancel is hidden behind here. So that flip button routine we saw before in the hierarchy chart will actually make all these disappear and bring the update and the cancel to make them appear. So all we'd see is this. So if a user wants to do an add, we don't want them to do anything else like exit out of the program or save or cancel. We want him to basically update or cancel if he wants to get out of that. So that puts us into place. But making all this happen, this is what we actually want to do. So let's go ahead and build this piece and make this all happen for us. What I've done is basically taken all the fields from the previous database, the version 3 version of the Anything database, and copied everything to my form, so they're all sitting here. So as you saw in the last slide, all these things are sitting there and they're named. As you can see, I can just jump to any one of these guys and you can see the text first name is sitting right here, middle initials here, last name here, and so on. Button delete is sitting over here, button search is sitting over here, and we got this guy up here, this label user message is sitting up in this particular area. So all those things are named for us according to that chart you saw in the slide presentation a few minutes ago. So all we need now is to start deciding how we're going to do the coding on this thing. I mentioned before we need a class. And so what we're going to be doing is we're going to be creating the person class to actually make this all happen. And how do we do that? Well, what we do is we go into our Anything database here and we right click on it and we say add a class. And we'll name that class person. And once I've done that, we get our initial code for this thing. Now, this is going to be the Anything database version 4 demo namespace. Our class is person right in here. What I want to do is I want to be able to create something that's going to hold all of my data and allow me to work with it. So we want to set up something like that. So what I'm going to do first of all is I'm going to grab the fields that I'm going to be requiring inside this particular class. I'm going to pop them in there like this. Now we've got our fields. Our string first name, string middle initial, last name, address line 1, address line 2, city, state, and zip are all sitting in here as a fields that we want to be able to have in our person class. I also want to be able to construct these things so that they are a certain size. So if somebody types in a last name of Smith, I want it to be 15 characters long, SMITH with 10 blanks. So I'm going to require a variable to be in that I can use in my class to make this thing work. So I'm going to pop that thing in right here. I've got str 35 blanks, and here's 35 blanks right here, and it's a utility variable that I'm going to be using. So that's all I need there. The next thing I want to do is I want to set up a constructor. So what I'm going to do is I'm going to set this up right here as my constructor. Public person. This string first name is equal to empty. We're going to set it up as blanks right away, so it's there. But these are my constructors right in there. Then I'm going to actually do my gets and sets to make this thing work. Getting isn't going to be a problem. I simply want to return what's there. But setting is going to be different. I want to actually make the field that I'm going to be creating the size I want it to be. So let's start with first name. We're going to actually have to have something to our get and sets for the first name here, and we'll do that. What I'm going to do is I'm going to set up a get. In fact, let's go ahead and do it like this. I'm going to use a comment in here to tell me that my first name is going to be strf name. And so if I want to get this thing, I'm going to use person string f name to bring in the data. It's going to return str first name to the calling program. Now, how are we going to get the first name into here if we're actually saving it from what the user typed in? There we're going to be using a method. And the method's going to look something like this. Void format first name string strf name. So someone's going to be able to type in the first name in our text field. We're going to bring across, pass it over to this particular function, and call the format first name function, which is going to turn around and it's going to take the first name and create it by taking str first name plus those blanks we see up here, and then start in position 0 and only chop off the first 15 and store those in str first name. So if Smith comes in, SMITH plus 10 blanks are going to be stored in this first name field. So if we want to get it back, return str first name, we'd actually be getting SMITH with 10 blanks attached to it, and so on down the line. Now I want to do this with everything else in here, so I want to do the middle initial and bring that in. That looks something like this. Middle initial's coming in, we're going to return MI. We're going to get mid, str mid, and we're going to take it and we're going to grab one blank to it and just 0 to 1. Nothing might have come in the middle initial, so we're going to bring in a space, so at least we have one space in this particular thing when we actually get it. The last name field is going to be very similar to the first name. It's going to look like that. str last name, and again, we're taking our 20 blank. We're using 20 characters for creating our last name field. Our address line 1 and address line 2, I'll do those together and just bring those things across. And that's going to look something like this. our address line 1, we're going to bring in str. We're going to get str at line 1 is going to be coming out of this thing, but we want to bring it in. If the user types in an address line 1, we're going to take that address line, add the blanks to it, and take the first 35 characters out of it and store that in our address line 1. Same with address line 2. Same thing. 35 characters long. Whatever you typed in, add the 35 blanks to it, and then chop it off, and from 0 to 35, save that in our field. So we've got that record saved. City looks something like this. We're going to return str city. We're bringing in str cty, and we're taking the blanks and we're allowing the city to be 25 characters long. State looks something like this. Str st. We're going to return str state, but to get it, we're going to bring in str st, and we're going to add a couple of blanks to that thing, and then make it the first 2 characters. So all our states are going to be 2 characters long. We could go beyond this and make them all uppercase too if we wanted to add more functionality to this thing and make it all happen. And again, it can be happening in the class that we're actually doing this particular. Zip code looks something like this. Returning str zip. If we're getting it from the user, str zip code is being passed, and 5 blanks are being added to the zip code, and then we're truncating from 0 to 5. So if there's no zip code is entered, we'll get 5 blanks. If something is entered, we should get the 5 characters. If we get something sloppy in there, like 532 blank blank, it's an error which we're not checking for, but we could actually have that come into our database and make it all happen. But we'll have an edit procedure later where we can actually correct anything that's wrong with our database data that's actually in there. That's it for the class right now. Now, this is rather large, as you can see. We didn't see this in examples. We're looking at, oh my God, this is one single class. Yeah, it is, because it's using a lot of fields and everything. It's kind of big, but it's going to be very powerful when we actually make this thing work and make it actually useful for us. And there's a few things we haven't done with this particular database that we're likely going to want to do and change by adding something to this class later. One of them is being able to save the data. We want to be able to, in the past, we did the comma delimited thing in the program itself. We may want to do that right in here and make it part of our class to actually create the comma delimited file by bringing all the fields in and concatenating them into a comma delimited string record. And then passing that on, let the program just simply save it to disk and not do any work at all. In other words, the person that writes the class can be the person that dictates how this data is supposed to be saved, how it's supposed to be assembled when we actually use it, and any other program we now can grab it, and as long as they understand that they're going to be using the format keys to get and set the data in this particular class, they're going to be able to do something consistent no matter which programmer you give it to. So we may be adding to this, and that's okay with the class. We've designed it so far, it's going to work for now, but we're probably going to add some things to it, and that's perfectly okay to actually do that as you go forward. So that's our class so far. We've actually done that and created that. What else do we need to do? Well, we're going to do some creative work in our form itself. So I'm going to go out to the form, and I'm going to go out to my code in here. This is what we actually have here. Actually, what I'm going to do is I'm going to go ahead and click on the exit button and program this right away by simply putting in our close. This gets it out of the way. We don't have to worry about it later. There's no reason to be working with this after we've got that done. So we can, now our exit button will function. And we also want to do something with form load. So I'm going to click on the form itself right here and get my form load here. And in there, what I want to do is I want to actually put an in record counter equal to 0 in here. And then I want to display that in my label. But that also is going to mean I'm going to have to define these things. So I'll do that up here and create some utility variables. And I'll put those utility variables right here. So we're going to have an in record count. We're going to have in record pointer label because we're going to want to point to the record in the list, but not the list. It's actually going to be in our, well, it will be a list because we're going to save it in a list. We're going to be able to save our classes, our instance of the class in a list as we go forward in this thing. So it is going to be a list of some kind that we're actually going to have in there and make that all work. We're also going to have an ability to have a Boolean telling us whether we're adding or editing in the field, and we'll extend this later when we start doing searching. For right now, this is enough to make this program function so we can actually work with it and make it all happen. So that's putting our piece together. Does it work? Do a file save all. Yeah, it does. stuff's there. I can't do anything in here. I can't hit the buttons, but they won't work except the exit button. It'll all work. So, but we've got our piece together, and all that functionality is there, and our class is there too. We haven't used it yet, but it's there. So we're all set. We've designed our form. We've designed the class, and we've got the beginnings of our program. The next thing we want to do is we want to be able to add data and see what happens there. And we'll do that in part 2. As you can see, the coding for the class was quite a bit larger than anything we did in the lessons up to now. It helps, I think, to understand that classes are nothing more than programs you can call for your application. Seeing a larger application takes away the mystery of the class, I believe. At least it did for me. In the next video, we're going to put that class to work and add records to our application. Thanks for watching. Visit the website when you get a chance. And please subscribe to the channel. There's something new coming every week. I'll see you in the next video. Take care.